Okay, so this video is going to be about the last log rule that is given to you and how to use all of these rules with basic equations. So the final rule that we haven't learned about yet, we know the product rule, the quotient rule, and the power rule. The final rule that we have to learn is the change of base rule. So the change of base rule just says if I have something log base a of b, I need to change that, or I can change that, to be the log base 10 of b divided by the log base 10 of a. This means that I can change the base of whatever it was originally in an a, let's say it was like a 2 or a 3 or an 8, and make it into base 10 here and here. That way I can use my calculator to just solve for the base or solve for the logs using the common logs when there's a base of 10. So it basically tells you we can switch everything to base 10 by taking the log of b divided by the log of a. So let's take an example here. Log base 3 of 243. All I want to do right now is switch this into common log, so base 10, using change of base rule. So if I were to do that, I would just say, instead of the log base 3 of 243, it becomes the log of 243 base 10 divided by the log of 3 base 10. This helps us out because I can use my calculator to solve for the log of 243 divided by the log of 3. It will get me some sort of decimal, but for right now, I just want to make sure that I can set it up. Let's try another. Log base 5 of 34. Change of base, put it into common log. I could say this is the same thing as log of 34 base 10 divided by log of 5. Now, I want to be super clear. This is not the same thing as log of 34 divided by 5. If you put that in your calculator, these two different logarithms will not equal the same amount. So we have to be super careful about that. Okay, then let's try one more. The log base 9 of 86. Well, I can change that using the change of base. This is now the log base 10 of 86 divided by the log base 10 of 9. Again, I can use my calculator to get decimals, but right now I'm just going to practice the switch. Alright, here's one more. Well, now I have the log base 3 of 287 equals x. So now I know two different things that I could do. The first is I could use my little circular rule and put this into exponential form, saying 3 to the x equals 287, and then try to figure out what x equals. We've done that before, and a lot of the times right now we only know how to guess and check. The other thing I could do using my calculator is do the change of base. So I could say, well, this is the same thing as saying log of 287 divided by the log of 3. Now I've changed both of these into base 10. Remember that when it's base 10, we don't actually even write it, but there is a 10 here and here. And now I can use my calculator to actually estimate this value of log of 287 divided by log of 3. Let's go ahead and do that. In our calculators, what you can do is take the log of 287, put it in your calculator, and you get about 2.45788819, etc., etc., etc. But what I would rather have you do is just take the entire problem and punch it in. So in your calculator, it would look like log 287 divided by log of 3. And when you get that, what your answer should be is approximately 5.15148 ... So let's just round it to 2 decimal points, or to the nearest hundredth. So it's about 5.15. Okay, let's do one more. The log base 4 of 68 equals x minus 3. Well, again, I could try to use my circular method and put this into exponential form, but now we're going to get even more tricky than we've ever dealt with before. This would be 4 to the x minus 3 equals 68. Now, I would still try to figure out what x minus 3 should be to get to 68, but that's a lot of guessing checking for now. So instead, what I could do is set this up. Instead of log base 4 of 68, I could write log of 68 over log of 4 equals x minus 3. Minus 3. Ooh, excuse me. Okay. So then what I could do is actually get this value of log of 68 over 4, log of 4. So if you punch that into your calculator, you get approximately 3.0437. So if I wanted to rewrite this here as 3.0437 is equal to x minus 3. Well, now I just have an equation. If I want to solve for x, I add 3 to both sides, and x equals about 6.0437. And that would be my answer. It didn't tell me any rounding, like directions, so right now that whole 6.0437 is just fine. Now that we know the change of base, we know all of the rules of logs, product rule, quotient rule, change of base, and power rule, I want us to use logs to solve exponential equations. So in the past so far, and even in this video, we've asked ourselves 2 to the x power equals 4,536. Well, I don't actually know what x is equal to. I do know that I can guess and check. I can use my calculator. I can try to get as close as possible to what number that might be. But I also know that I can use logarithms and use the power rule, which means log base x to the a can still be the same as a times log of x to bring that exponent down. So just like we did up here in this equation right here, we could add 3 to both sides of an equation. We can do anything to both sides of an equation. We can multiply, we can add, we can divide. We've done a lot of work with that since like middle school math. But now we can say, okay, we actually know how to use logarithms now. And what we can do is we can take the log of both sides. So when I see this equation here, I see 2 to the x is equal to 4,536. Well, I can take the log of both sides. And when I do that, it doesn't change the value of the equation because I'm still doing it to both sides. Now on the right side, log of 4,536, that's just a number. Now with the power rule says I can bring this x down and in front. So I can now say this is x times the log of 2 is equal to the log of 4,536. Now, again, log of 4,536 and log of 2 are just numbers. So if I wanted to isolate for x, well, just like if it was 2x equals 6, I would divide by 2 on both sides to get rid of that and have x alone. Same thing I can do here. I can just divide by the log of 2 on both sides because log of 2 over log of 2 is just 1. But because it's an equation, I'm going to divide by both sides. That means x equals the log of 4,536 divided by the log of 2. Now I can go into my calculator and do that, and I can say what is the log of 4,536 divided by the log of 2, and I can get an approximation of about 12.147. So now I've solved for x. That means if I plugged this all the way back in as x as the original equation here, I should get approximately 4,536 2 to the 12.147 power gets me that. All right, let's use that now, our knowledge there, to make sure that we can answer the next two problems. So I want you to pause. I want you to try this by yourself first. 5 to the x power equals 1500. And then we'll solve it together. So 5 to the x equals 1500. Well, I want to make sure that the exponent comes down because I don't know off the top of my head what power that could be. So what I can do is just take the log of both sides. Sorry, this is so messy. If I take the log of both sides, now I can say that the x can come down and in front. Now I have x times the log of 5 equals the log of 1500. I can say, well, the log of 5 is just a number, so let me just divide by it on both sides. And now x becomes the log of 1500 over the log of 5. And if I want to do that in my calculator to get an answer or an estimate of the decimal point, that should be 4.5439-ish. So that's x. Again, try this on your own. This next one, 6 to the x minus 1 equals 7,776. And then we'll do it together. So 6 to the x minus 1 equals this. Again, I don't know off the top of my head what 6 to the power of what gives me gives me 7,776. So I have to think about how I could do this myself. Well, I can put the log on both sides. Log of 7,776. And I can use my power rule. Power rule says that this exponent here can come down in front. So I could say x minus 1, that whole power is being multiplied by the log of 6 equals the log of 7,776. Cool. Again, I want to solve for x, so I can just divide by the log of 6 on both sides, because then I'm balancing my equation. Now, this time, I am not done. I have x minus 1 equals this, so I really could just write plus 1 to the other side and cancel it out. So x equals this whole thing, the log of 7,776 divided by the log of 6 plus 1, or I could get an approximation of that number. Log of 7,776 divided by the log of 6, that's actually 5. 5 plus 1 just means that x equals 6. And we're done. So even when there's more than one thing in the exponent, we're still able to use our logarithmic rules to solve for x. Now this is step 1 of a lot of different ways we can use logs in equations, but this is the most simple, and I wanted to make sure that you have like a good sense of how we can use logs once we have this exam, and then we'll bring it back after winter break. So you are done.